In today's video, I'm going to go through some similar shape questions, just these three. You can download them in the description below. I try them first on my own. Well, you try them on your own and then watch this. Usually it's a bit easier, well, not saying easier, but it's better if you try and do them yourself first and get stuck and then kind of look at the video and then, oh, okay, that's how it's done. Or you can just watch the video, but yeah, I would always suggest trying it on your own first. Cool, so these three are a little bit different than the usual similar shapes that we get. So let's take a look at it. The small box is mathematically similar to the large box. Okay, these are the same. They say the volume of the large box is 72.8% greater than the volume of the small box. And the small box has a length of 3.5 and the large box has a length of x. Now usually, so calculate the value of x. Okay, that's obvious. So usually when we have volumes, they might give a volume like 1,000 cubic centimeters, and another one is maybe 50 cubic centimeters, and then we would compare these two by either writing 50 over 1,000 or 1,000 over 50, depending on, if you want to go bigger or smaller. But in this case, we have a 72.8% increase. So we have a small, and then we're going to multiply it by some value to get the bigger one. And they're telling us that this one is 72.8% bigger. If you think about it, if you wanted to increase the size of, let's say, something by 50%, let's say there was a price of $100, let's make it $100, yeah, $100 or something. If you have $100 and you want to increase it by, 50%, then we can usually say 100 times 1.5. And this 0.5 will increase it by 50%. So our answer will be 150. Or if it was 5%, we would multiply by 1.05. Or if it was, 10%, we would multiply by 1.1. Or 15% would be multiplied by 1.15. So in this case, we're increasing by 72.8%. So if we're going to have a multiplier, it's going to be 1.728. Whatever the small value is, I'm going to have to multiply it by this number to make it 72.8% bigger. So this is basically the scale factor. But the important bit to remember is this is for volume. Okay, let me just clear up a lot of this stuff. Okay, so if I think about it, I have a small to large, and my scale factor is 1.728. But this is for volume. So if I wanted to get the scale factor for length, I'd have to take this number and I have to cube root it, because that will give me the scale factor for length. And then I'll know what to multiply the small, let's say the small number by, or the small length by, to get to the large length. So basically it's just this 3.5 multiplied by the cube root of 1.728. And that would give us an answer of 4.2 centimeters. And yeah, I think it looks very simple like this, but I don't think it's as intuitive as the previous, let's say, past paper questions we've seen. Well, when it comes to similar shapes. Okay, that was that one. Quick one. Let's say the next one, there's a warehouse floor area that is 800 square meters. And the plan. So we have a plan and we have, I guess, real life or actual guess. And the scale is 1 to 50. So it means that if there's something on the plan, let's say 1 centimeter on the plan would be 50 centimeters in real life. So what did I do here? I multiplied by 50. So my scale factor is now not something I have to work out in a diagram or something. It's actually given to me in this form 1 to 50. So it's going to be anything in the plan is going to be multiplied by 50 to get to real life. And in the real life, I have to divide. If I go the other way, I'm going to have to divide by 50, or I can multiply by the reciprocal, right? So anything in real life is going to be multiplied by 1 over 50 to get to this, the plan lengths. Now, on a plan, we usually work with lengths, and here they're talking about 800 square meters. So this is length, but we have to work with a area, and they're telling us the real life area. Let me just shift this over. Area. We have to work with this 800 square meter area, and we have to figure out what the area is on the plan. But they also give this little bit of information here that our answer has to be in centimeters. So for now, I'm just going to use meters to get my answer. And I know that I have to multiply by this 1 over 50 to get from real life, or the actual values, to the plan values. But this is length. So in order to get it for area, I'm going to have to actually square this. So I'm going to rewrite it maybe just from left to right to make it a little bit easier. So I'm going to have to take the 800. I'm going to multiply it by my scale factor for length, but I need to square it because I'm going to go into area. I have to compare area. And this would give me, on the calculator, I did this and I got 0.32. Now, this is not my final answer because I'm still in square meters. Now, there's 100 centimeters in 1 square meter. So I have to kind of now convert this. So usually I'll take 1.32, well, not usually, but this number I would have to multiply by 100. If this was meters, I'll have to multiply by 100 to get to centimeters. But again, now I'm using area. So I have to multiply by 100 squared, which is 10,000. So it would be 0.32 times 100 squared, or times 10,000. And then I would get 3,200 square centimeters. Okay, as simple as that. I think here it's just making sure that you understand that, that you're going from square meters to square centimeters, and not like just thinking this is your final answer. Okay, for the last one, let's just rub this out. This one has some extra bit of reading inside, so let's just go into this. It says 2 solid steel statues are mathematically similar. The smaller statue has a height of 12 and the larger one has a height of 15. So because they're giving us the 2 lengths already, I know the scale factor, or the multiplier, is going to be 12 over 15. Or it can be 15 over 12, depending. If I want to go from the large to the small, I'll have to multiply by the 12 over 15. And if I have the large, small, and I want to go to the large, I'll multiply by 15 over 12. Okay, if you're kind of not sure where this comes from, maybe look at some of the other videos that I've made, but I think this is pretty much straightforward. So we know for length, there's 12 over 15 or 15 over 12. Okay, same thing for us. The largest statue has a mass. Oh my goodness, we have mass now, which is not something we usually see in mathematically similar shapes. We kind of used to seeing volume and, I don't know, area, but now we have a mass. Okay, a larger statue has a mass of 2.5 kilograms. I'm just going to go here, small and large, just to keep things simple. So that's 2.5 kilograms. Okay. And the density, like suddenly we're in physics now. The density of steel is 8 grams per cubic centimeter. Calculate the volume of the smaller statue. Oh dear. Okay, so for the larger statue, I would have density because both are made from steel. So the density would be the same. And then the mass of the larger one I have. So I'm going to have to, instead of them giving me the volume straightforward, I'm going to have to work out the volume using this little equation. So the density is 8 and the mass is 2.5, but this is a little bit of an issue because you see this is 8 grams per cubic centimeter, and there we have 2.5 kilograms. So I can't use this 8 and then 2.5 kilograms. I'll have to use grams. So I'll have to do 2.5 times 1,000, which will give me 2,500. So this mass should be 2,500, and then divided by the volume. And if I rearrange this, then volume is just going to be the 2,500 divided by 8. And that would give me 312.5. Okay, so this is my volume. So, and this is in cubic centimeters. So, yeah, that's fine. But now I have to get to the smaller volume. And they're saying calculate the volume of the smaller statue. So because I'm going from large to small, I'm going to choose this, because I can see the smaller number is at the top and the bigger number is at the bottom. So if I multiply with this, it's less than 1, so the number should get smaller. So I'm definitely going to use the 12/15, but I have volume here, and that is for length. So in order to use my length for volume, I'm going to have to do kind of this little trick. So let me just rewrite that from left to right so that it makes a little bit more sense. I'm starting with a large value, which is 312.5, and I'm multiplying by the scale factor 12/15, but this is for length. So because I want volume, I'm going to cube it. If I wanted area, I'd square it. But okay, cubing this, and if I work this out, I should get a nice number like 160 centimeters cubed. And there you have it.